Constant rate of change, Lesson 3.1. The standard is 8EE5 and 8F4. The objective is to identify proportional and non-proportional linear relationships by finding a constant rate of change. Essential question: why are graphs helpful? Vocabulary: linear relationship, when graphing a set of coordinates that make a straight line. Constant rate of change, the rate of change between any 2 points in a linear relationship is the same or constant. It will make a straight line when graphed. The rate of change. To find the rate of change, you take the change in y and divide by the change in x. Proportional relationships do two things. They go through the origin and make a straight line. A constant rate of change will always make a straight line. Example number 1. The balance in an account after several transactions is shown. Is the relationship between the balance and the number of transactions linear? If so, find the constant rate of change. If not, explain your reasoning. So first, we're going to start off by labeling our columns. The column on the left is always the x values. The column on the right are always all of my y values. And I know that the rate of change is the change in y over the change in x. So we're going to start with our y values. So from 170 to 140, we're decreasing by 30. From 140 to 110, we're decreasing by 30. And then from 110 to 80, we're decreasing by 30. So they are constant because they're all decreasing by 30. Now let's do our x values. From 3 to 6, we are increasing by 3. From 6 to 9, we're increasing by 3. And from 9 to 12, we're increasing by 3. So they are constant because they're all increasing by 3. So the change in y is a negative 30, and the change in x is a positive 3. So negative 30 divided by a positive 3 will give me negative 10. However, we are talking about money, so I need my dollar sign. So it would be negative $10. So since my y values and my x values are all constant, this is linear. So yes, it's linear. Because it has a constant rate of change. Example number 2. The amount a babysitter charges is shown. Is the relationship between the number of hours and the amount charged linear? If so, find the constant rate of change. If not, explain your reasoning. So first, we're going to start by labeling our columns. The first column is all of our x values. The second column is all of our y values. So I know that the rate of change is the change in y over the change in x. So first we're going to start with our y values. From 10 to 18, we're increasing by 8. From 18 to 26, we're increasing by 8. And from 26 to 34, we're increasing by 8. Since we're increasing by 8 on all of them, that means it is constant. Now let's move on to our x values. From 1 to 2, we're increasing by 1. From 2 to 3, we're increasing by 1. From 3 to 4, we're increasing by 1. Since we're increasing by 1 for all of them, it is constant. So our change in y is $8. Our change in x is 1 hour. That means it's $8 per hour. So we're increasing $8 per hour. That means that yes, it's linear. Because it has a constant rate of change. Example number 3. Use the table to determine if there's a proportional linear relationship between a temperature in degrees Fahrenheit and a temperature in degrees Celsius. Find the rate of change. So we're going to find the rate of change first. And I know that the rate of change is the change in y over the change in x, which is also my rise over my run. And we know the rise over the run as slope. So first I'm going to select 2 points. I'm going to select 10, 50 and 15, 59. So I'm going to do my change in y first. That's my rise. So I'm going to go up. And I'm looking at my y values. From 50 to 59, I'm increasing by 9. So that's my change in y. Now my change in x, which is my run. I'm going across. My x values from 10 to 15, I'm increasing by 5. So that's my change in x. That means that my rate of change is 9 over 5. Now they're asking me to find out if this is a proportional linear relationship. Well, I notice it does not start at the origin. Since it doesn't start at the origin, that means this is not proportional. So it's not proportional. Because it does not go through the origin.